Alright friends, welcome back. We are in the new video series JavaScript Numbers, and in this first video of JavaScript Numbers I have a lot of explaining to do, a lot of theory to be covered. JavaScript Numbers has only one type. Okay, JavaScript number has one type of numerical representation, and that is number. And numbers can be written with or without decimals. These are important touch points. You may want to take notes. JavaScript numbers can be written with or without decimals. For example, okay, var x is equal to 44.00. okay, and this is a number. Don't worry, I'm not going to run this code. I am not writing code, I'm just explaining the basics right now. This is a number with decimals. Okay, and then for example, another example, var 44. Okay, end of statement marker for both of them. Now this is a number without decimals. Okay, extra large or extra small numbers can be written with scientific or exponent notation like this. For example, how do you write exponent or raised to the power of? Var x is equal to 123 exponent 5. Okay, that's how you write 1 2 3 with 5 zeros. 1 2 3 4 5. Okay, 123,000. No, it's actually, I think, 1,230,000. more than that, I think. All right, let's not get into those numbers. So we have var y is equal to 123 e minus 5. Okay, so this is going to be in decimals. Okay, watch how we do it in decimals. It's 0.00123. all right, how many decimal places? 5. 1 2 3 4 5. Doesn't mean you have to have that many zeros, but for exponent 5 you need that many zeros. 1 2 3 4 5. all right, what else do we have? Okay, the other thing that I have here is the JavaScript numbers are always 64-bit floating points. Okay, JavaScript, okay, let me begin with the fresh line here. Yes, JavaScript numbers are always 64-bit floating point numbers. Unlike many other programming languages, JavaScript does not define different types of numbers like integers, short, long, float. Okay, so you have no integer, no short, no long, no float. Okay, anything, you have nothing. Just one kind of number, that is the number itself. That's it. Okay, so, and JavaScript numbers are always stored. They are stored as double precision floating point numbers, and they follow the international IEEE 754 standard. Okay, you can look it up, it's beyond the scope of this video. IEEE 754 standard, it defines how numbers are declared or how they are written down. Okay, this format stores numbers in 64 bits. Okay, which is why the floating point is in 64 bits, where the number or the fraction is stored in bits 0 to 51, the exponent in bits 52 to 62, and 52 bits 0 to 51. So value of a fraction is in bits. All right, let me explain this to you with the aid of an example. Okay, let me delete this and be right. Okay, so let's look at how the JavaScript numbers are written in precision. Okay, just copy this code and run this program, and I will explain what's happening in what statement. Okay, JavaScript, begin with doc type HTML. Open up the HTML tag, open up the body tag, open up the paragraph tag, and say integers are considered accurate up to 15 digits. Okay, and close the paragraph tag. Open up the button tag and say button on click is equal to my function. Okay, and then you need to say try it. Okay, and button, and then open up the other paragraph tag and say id is equal to demo, and close the paragraph tag. Okay, open up the script tag and say function my function, open up the curly bracket and say enter and tab var x is equal to write 99999999999, and I need you to write this at least 15 times. And var y, hit tab, say var y. I'm just showing you how big numbers are written with precision. 999999. Okay, 15 times. And tab document dot get element by id demo dot inner html is equal to x plus x small x plus arrow break, you concatenating. All right, add a break and close the bracket and add inverted commas, closed, plus y. Okay, and let's open up the curly bracket, close the curly bracket, sorry, and close the script tag, and also close the body tag, and close the HTML tag. Okay, let's save this file. All right, let's save this file. I've already saved it as JavaScript numbers, but I want to save it as HTML.html. All right, and let me find this file. JavaScript numbers.html. J is at the top. JavaScript numbers. Okay, integers are considered accurate up to 15 digits. Okay, so it's going to round off. Okay, so as you can see, the JavaScript numbers are accurate up to 15 digits. Okay, beyond which it's going to round it off to the nearest number. Let's look at another example. Let me delete the screen so that I can reinforce what I'm trying to teach you. Okay, let's begin typing this second program. I'm going to save it as JavaScript numbers 2. Doc type HTML. Open up the HTML tag. Open up the body tag. Paragraph. Floating point arithmetic is not always 100% accurate. That's what we are going to accomplish in this code. Okay, some things are done automatically by JavaScript, and that's exactly what I'm trying to explain here, that by merely using the right function you can manipulate a given value and you can round it off to the next digit, a whole number. Okay, I'm just showing you the possibilities of JavaScript numbers. Okay, button, it has only one type of number, that's number, no integer, no boolean, no integer, no floating point. The precision is automatically calculated provided you invoke the right method. id is equal to demo Open up the script tag, function, my function, open up the curly bracket and say var x is equal to 0.2 plus 0.1. okay, and you have document dot get element by id demo dot inner html is equal to 0.2 plus 0.1 is equal to, the answer is plus x. okay, and what happens when you try to compute these small numbers? Okay, let's find out when we run this code. And the script tag and the body tag and the HTML tag. Let's save the file. Alright, file, save as to, and also save as .html. Let's find this file. There you go. Floating point arithmetic is not always 100% accurate. For example, 0.2 plus 0.1 is 0.3 and all of these zeros, 4, which is not a lot of fun to read. Okay, even I am not, who's going to read all of these zeros out? And what if you want to perform further calculation? So, which is why we're trying to accomplish here that floating point arithmetic is not always 100% accurate. Okay, let's look at the other example and then I'm going to sum it up. Alright, let's look at the other example that I have here for you. Begin typing, and it's linked with the current example that you just accomplished here. Okay, doc type HTML, open up HTML tag, open up body tag, open up paragraph tag and say floating point arithmetic is not always 100% accurate. Okay, but in the other line I want you to write but it helps to multiply and divide, because multiplication and division, which is further computation, becomes more accurate, but you need to display it. You don't want to display it with so many floating point numbers. Button on click is equal to my function. Okay, execute my function when this button is clicked and the label of this button says try it. Alright, open a paragraph and say id is equal to demo. Close the paragraph tag. Okay, and open up the script tag and say function, my function, open up the curly bracket, hit enter and tab, var x is equal to, open up the bracket, 0.2 multiplied by 10 plus 0.1 multiplied by 10 divided by 10. Okay, hit enter and tab and say document dot get element by id demo dot inner html is equal to 0.2 plus 0.1 is equal to plus x. Close the curly bracket and close the script tag, close the body tag and close the HTML tag. Perfect. Let's save this file. Okay, and file save as JavaScript Numbers 3 and also save it as .html. Let's find this file. There you go. Floating point arithmetic is not always 100% accurate, but it helps to multiply and divide. Okay, 0.2 plus 0.1 is equal to 0.3, and that's much better than the previous example in which you did 0.2 plus 0.1 is equal to 0.3 and all those extra zeros. But in this example, you did the whole thing divided by 10 to calculate the precision points. Okay, so in these examples, what I was trying to say is that JavaScript numbers are going to be accurate up to 15 digits. This 9 up to 15 that you wrote was accurate up to 15 digits. Anything more than that would be rounded off to the next number, to the next whole number. Okay, and to the next 100, to the next 10, to the next 5. So, but the JavaScript precision, in order to obtain precision, you will be able to receive precision by multiplying and dividing, just like we did here. So instead of having a 0.2 plus 0.1 is equal to all of these numbers, if you divide it by 10, you will be able to get a better accurate answer. 0.2 multiplied by 10 plus 0.1 multiplied by 10 divided by 10. Okay, so with this I'm going to end this video, and up next I'm going to talk about hexadecimals. Okay, try to find out what's a 64-bit encoding. Try to discover why 64-bit encoding is used, and the value of 32-bit and 64-bit in JavaScript. Try to read it up, and the IEEE 754 standard, try to read that up as well before we go to the next video. In the next video, I'm going to talk about JavaScript hexadecimal with lots of examples to explain. Alright, so remember, the only reason why JavaScript numbers is a little bit complicated is because you don't have any other kind of number type. You don't have integer, float or anything else. You just have number, and you have to find a way of representing it accurately. Alright, so let's see you in the next video. Take care.